Hey friends, so now we are going to solve one more numerical on Fourier expansion, and we have to find out Fourier expansion of cos of px in 0 to 2 pi, and after that we have to deduce the given result. So guys, the deduction we'll see afterwards. First, let's find out the Fourier series for cos of px. So how to get this? So Fourier series for any periodic function in 0 comma 2 pi in this interval is given by one formula, and I've already explained you that formula in the previous video. So let's write down that formula. So here I'll say so guys, this is what the formula is. So if you don't remember this, then you just have to go in the previous video, that is what is Fourier series. In that I've explained you the series which is I've written here. So for time being I'm giving this as equation number 1. So I'm keeping this, or I'm making this as equation number 1. Now guys, to get the Fourier series or Fourier expansion of cos of px in terms of sine and cos, we have to first of all evaluate the unknowns. So here the unknowns are a0, an and bn. So let's evaluate it. So the formula for a0 is, it is 1 by 2 pi integration 0 to 2 pi f of x dx. Now the value of f of x is given here, which is cos px. So here I'll say it is 1 by 2 pi integration 0 to 2 pi cos of px dx. Now guys, what is integration of cos px? So 1 by 2 pi as it is, and here the integration of cos px is sine of px whole upon p, and this one is from 0 to 2 pi. So guys, integration sine px upon the derivative of px, which is p. So in this, now I'll put upper limit as 2 pi and then lower limit as 0. So when we'll put this x as 2 pi, we will get sine of 2p pi. Now guys, here I'll write down that term. So a0 equal to now let's put the lower limit. So lower limit is 0. So when I'll put it here, we'll get sine of p into 0, that is 0. So here I'll say minus the lower limit is 0. Now guys, the value of p is not given. So let's see in the question, p is not defined. So we don't know whether it is integer or it's a fraction, because based on that this value will vary. So don't misunderstand this as sine of 2n pi, because it's 0. And here in this formula we know that n is integer, but here p is not given as integer. So we can't say that whether it will be 0 or some value. So we'll keep this value as it is, and therefore I would say the value of an, here I'll write down, therefore the value of an is, a0, the first value is a0, is sine of 2p pi whole upon 2 pi p. So this is the value that we got for a0. Now let's find out an. So the formula for an is 1 by pi integration 0 to 2 pi f of x cos of nx dx. So here f of x is given as cos of px, so this will become 1 by pi integration 0 to 2 pi cos of px into cos of nx dx. Now to evaluate this integration, we have to multiply these two cos terms. So here I'll use the result, that is cos A into cos B. So guys, here I'll write down that result for you. So 2 times cos A into cos B is given by cos of a plus b plus cos of a minus b. Now guys, here this a is px and b is nx, but 2 is not given, so I'll shift this 2 to the other side as 1 by 2. So here we will get answer as 1 by pi integration 0 to 2 pi 1 upon 2. So this 1 upon 2 has come because of this 2. Then in the bracket cos of a plus b, so px plus nx, if I add it, then I'll take x outside, so that will become p plus nx. So you can see here this is px plus nx plus cos of a minus b, so that is cos of p minus n into x dx. Now guys, this half will come outside and that will become 1 by 2 pi. So here I'll write down, so that is 1 upon 2 pi, and for these two terms we'll evaluate the integration. So what is integration of cos of p plus n into x? So it's sine of p plus n into x upon derivative of this, which is p plus n, plus here it is sine of p minus n into x upon derivative of this, which is p minus n, and this is from 0 to 2 pi. Now guys, let's put upper limit and lower limit over here. So upper limit is 2 pi, so we'll get 1 upon 2 pi. Now we'll write down the values in curly bracket. So in curly bracket the first value, so that will become sine of p plus n into 2 pi upon p plus n plus sine of p minus n into 2 pi upon p minus n. So guys, this is the value which we got due to upper limit. Now middle sign is negative. Now we'll put the lower limit, which is 0. So when we put 0, we'll get sine 0, that is 0, and this is sine 0 0. So we'll get whole result as 0. So the second term is 0. Now let's solve these two terms. So here we will get 1 upon 2 pi as it is, and we'll get some values for this. Now guys, to find out value of these two terms, what I'll do is I'll solve these two terms separately. So here I'll say the value of sine of, I'll take 2 pi inside, so that will become 2 pi p plus or minus 2 pi n. Now see here, this sign is plus and this sign is minus. So what I'm doing is for both the terms I'm finding the result outside itself. So here we'll get a formula of sine A plus or minus B, or you might use a formula of sine of 2 pi n plus or minus theta. So few students, they don't know the formula of that, so you should use sine of A plus or minus B. So that will become sine of 2 pi p into cos of 2 pi n plus or minus cos of 2 pi p into sine of 2 pi n. Now guys, we know the value of sine of 2 pi n is 0 and cos of 2 pi n is 1. So this term is 0. This is 1 into sine of 2 pi p is equal to sine of 2 pi p. Now we'll put this value here in both the terms. So we'll get it is equal to 1 upon 2 pi into sine of 2p pi upon this plus sine of 2p pi upon this. So it means guys, we are getting sine of 2p pi in both the terms. So I can take it outside. So we'll get sine of 2p pi or sine of 2 pi p upon 2 pi. In the bracket we'll get 1 upon p plus n plus 1 upon p minus n. Now let's solve this. So by cross multiplication we will get p minus n plus p plus n upon, by multiplying these two terms we'll get p square minus n square, and here sine of 2 pi p upon 2 pi. So here n will be cancelled, we'll get 2p, and in 2p 2 and 2 will be cancelled, so we will get p by pi sine of 2 pi p upon p square minus n square as the value of an. So guys, here we got the value of an. Now next we'll find out the value of bn. So the formula for bn is bn equal to 1 by pi integration 0 to 2 pi f of x sin nx dx. Now what is f of x? F of x is cos of px into sine of nx dx. Now guys, how to evaluate this integration? So it's simple, we have to use here the formula of defactorization. So by defactorization, 2 times cos a into sine b is given by sine of a plus b minus sine of a minus b. So guys, I am going to use this formula. Now we don't have 2 here, so I'll shift 2 to the right hand side, so we'll get half here. So this is nothing but it is equal to 1 by pi integration 0 to 2 pi, then 1 by 2 here in the bracket. A is px and b is nx, so this will be px plus nx. I'll take x common, so sine of p plus n into x minus, similarly here we'll get sine of p minus n into x dx. So I'll take 1 by 2 outside, so that will become 1 upon 2 pi, and let's evaluate the integration. So integration of sine p plus n into x is negative cos of p plus n into x upon derivative of this term, that is p plus n. Next, so negative sign will remain as it is, and the derivative of sine, integration of sine is negative cos. So this negative sign and that negative sign of cos will become positive cos of p minus n into x upon p minus n from 0 to 2 pi. So guys, wherever it is possible, you can use the shortcut or you can change the sign directly before solving it. So that reduces the length of your questions, because in Fourier series generally the length of question is generally the length of the. So guys, wherever it is possible, we can substitute the shortcut or we can write down the signs directly, because in Fourier series the length of this sum is more, which is generally 2 to 3 pages, so you can save your time. Now let's put upper limit as 2 pi and lower limit as 0. So here we will get 1 by 2 pi. So upper limit is 2 pi. By doing that we will get in bracket negative cos of p plus n into 2 pi upon p plus n plus cos of p minus n into 2 pi upon p minus n. So this is the value of upper limit minus. Now let's put the lower limit. Lower limit is 0, so cos 0 is 1, so due to negative sign we'll get negative 1 upon p plus n, and this will be plus 1 upon p plus n. Now let's evaluate this term. So here we have cos of 2p pi, so I'll write here 2p pi because I'm taking 2 pi inside, plus or minus 2n pi. So what I did is I've taken both terms together, so here it is plus and here it is minus. Now the formula for this is cos a plus or minus b, so that is cos a cos b minus plus sin a sin b, so that is now guys, what is the value of sine of 2n pi? So sine of 2n pi is 0, so the second term will be 0, but the value of cos of 2n pi is 1. So this will become cos of 2p pi. So guys, this is the value which we'll get in the first term as well as in the second term. So let's see what we get here. So here we will get 1 by 2 pi negative cos of 2p pi upon p plus n plus cos of 2p pi upon p minus n. Now due to the negative sign, this term will become positive and this term will become negative. So we will get positive 1 upon p plus n and negative 1 upon p minus n. Now guys, let's solve these terms here. So I'll take first term and third term together because it has a term 1 upon p plus n common. So this will become 1 upon 2 pi. Inside the bracket 1 upon p plus n common from these two terms, and in the bracket we will get 1 from here, and from here negative cos of 2p pi. Similarly, from the second and the last term, I'll take negative 1 upon p minus n common. So in the bracket, from here we will get positive 1, and from here we will get negative cos of 2p pi. Now, in these two terms, the bracket 1 minus cos of 2p pi is common. So that will become 1 upon 2 pi. In bracket 1 minus cos of 2p pi, and the remaining terms, that is 1 upon p plus n minus 1 upon p minus n. So let's solve this. So this term I'll keep it as it is. So that is 1 minus cos of 2p pi whole upon 2 pi, and this is nothing but by cross multiplication p minus n, and here I'll multiply this term with negative 1. So negative 1 into p, negative p, and negative 1 into n is negative n, upon this into this, that is p square minus n square. Now here we can cancel p with negative p, and minus n is minus 2n, and that 2 will be cancelled with this 2. So we will get negative n upon pi from denominator because 2 and 2 cancelled. Then in bracket 1 minus cos of 2p pi from numerator, and from the denominator p square minus n square. So guys, this is the value of bn. So here we got the value of a naught, then an and bn, and now we'll put all these values in equation number 1. So here I'll say from equation number 1 by substituting the values of a naught, an and bn. So what is the value of a naught? So we know that in equation number 1 the left hand side is cos of px. So the value of a naught is, here we have that value, which is sine of 2p pi upon 2p pi. So here I'll say sine of 2p pi upon 2p pi plus, now summation an. So summation is from n equal to 1 to infinity. So what is the value of an? So guys, this is the value of an that we got. Now inside this summation I'll write this value, but guys, let me tell you that there are few terms which does not have n itself, like p, pi and sine 2p pi. So I can take these terms outside the summation because summation is for n equal to 1 to infinity, that is for the values of n. So inside the summation only 1 upon p square minus n square will remain. So we will get p sine of 2p pi upon pi, and in summation from n equal to 1 to infinity we will get 1 upon p square minus n square into cos nx. So cos nx I'll write here. Similarly, let's put the value of bn. So here this is the value of bn, in which this term does not have n, this term does not have n. So I can take these two terms outside the summation and also the negative sign. So we will get negative 1 minus cos of 2p pi whole upon pi, and in the summation we will get n equal to 1 to infinity n upon p square minus n square into sine of nx. So guys, here we get the Fourier series for cos of px. Now after this we'll start with the deduction. So now what is the deduction? So here let's see. So here we have to deduce that pi cosec pi x is equal to 1 by p plus summation n from 1 to infinity negative 1 raised to n 1 upon p plus n plus 1 upon p minus n. Now guys, how to get this deduction? So let's see the summation term. So inside the summation I want negative 1 raised to n in the numerator and p plus n, p minus n in the denominator. So p plus n, p minus n I can get in the denominator, but to get negative 1 raised to n here, we should put x as pi, because cos of n pi gives us minus 1 raised to n. Similarly, if you see the left hand side here, angle is pi x. So it clearly denotes that we should put x as pi. So if we put x equal to pi, then we can get here negative 1 raised to n, and then by substituting or reducing the terms we can get the answer. So let's start. So here I'll say put x equal to pi. So here we will get cos of p pi equal to, now what do we have here? So here one term is sine of 2p pi upon 2p pi. The second term is p into sine of 2p pi upon pi, and in the summation we have minus 1 raised to n upon p square minus n square. Now let's see the next term. So here if I put x equal to pi, I'll get sine n pi, and guys sine n pi is 0, therefore this whole term is 0. So it means we just have these two terms now. Now let's see the deduction. So in the deduction we want cosec pi x on the left hand side. So guys, there is a mistake in question. The question must be cosec of pi p, because we are substituting the value of x here. So I'll make this question as cosec of pi p. So it means we want cosec of pi p on left hand side. So for that we should bring 1 upon sine on the left hand side, and by doing that we can get the answer. So for that what we'll do is, to get 1 upon sine here, we have to cancel the cos, and to cancel the cos I'm gonna substitute the formula over here. So can you see sine of 2p pi in both the terms? So I can say sine of 2p pi is 2 times sine p pi into cos of p pi upon 2p pi plus p into 2 times sine of p pi into cos of p pi upon pi into summation negative 1 to the raised to n upon p square minus n square. Now guys, here we can cancel this 2. On the left hand side we have cos of p pi. Now guys, can you see that cos of p pi term is there on left hand side as well as on right hand side? So I can cancel this cos of p pi from LHS as well as from RHS from each term. So what we get? We get pi common in both the terms. So I can take it common, I can shift it to the left hand side. so that pi is in denominator, which is dividing, so it will go here and it will multiply. So here we have 1, so 1 into pi, we will get pi on the left hand side. Similarly, here sin p pi is the term which is there on the right hand side, so it is multiplying, so I'll shift it to the left hand side, that will go and divide, so that will become upon sine of p pi. Now what will remain on right hand side? So from here, pi gone, sin p pi gone, so only 1 by p is there, so 1 upon p plus, in the second term we took sin p pi and pi on the other side, so 2p is remaining, so here I'll say 2p, and in the summation negative 1 raised to n upon p square minus n square. Now let's move to the question again. So here in the question we want pi into cosec pi p. So here we got, so pi 1 upon sine is cosec pi p, or p pi you can say, equal to 1 by p. So as you can see here that I want a term like 1 by p. Now the thing is how to bring this term. So let's cross multiply this term here itself. So by doing the cross multiplication, what we'll get? We will get p minus n plus p plus n. So I can cancel n and n, I'll get 2p upon p square minus n square, that is multiplication of these two terms. And guys, if you see here, we already have 2p upon p square minus n square. So here I'll rewrite this term as summation negative 1 raised to n, and in the bracket 2p upon p square minus n square. And this term 2p upon p square minus n square is nothing but 1 upon p plus n plus 1 upon p minus n. So here we get pi cosec of pi p equal to 1 by p plus summation negative 1 raised to n into 1 upon p plus n plus 1 upon p minus n, and n is from 1 to infinity. So this bracket is nothing but 2p upon p square minus n square, and by doing this we got the deduction. So guys, here we have proved the given deduction as well as we have derived the Fourier series for cos of px. So I'm sure that you understood the whole process, how I got the result. And if you want to learn more videos on Fourier series and engineering mathematics, then guys stay tuned to Ekeeda.com, because that is the only platform where you can get all engineering lectures at one place, and you can find my lectures as well. Thank you very much.